Our next task is to configure BGP, and that's actually going to be pretty straightforward. So let's start with router 2, enable configure terminal, router BGP, and then autonomous system number here is 2500. Next, I'm going to list the external networks or the networks that are in BGP. These networks from OSPF, we are going to redistribute into BGP. So, network 5100, mask 255.255.255.252, and then neighbor is router 1. IP address there is 5101, and then remote autonomous system number is 2100. And that's it for now for our BGP configuration on router 2. Let's go to router 1. Enable configure terminal, router BGP 2100. We had 2500 here. Here it's 2100. We have two external networks on router 1. 5100, mask 255.255.255.252, and then network 5200, mask 255.255.255.252. Neighbors are 5102 with remote autonomous system number 2500. And then we have neighbor 5202 with remote autonomous system number 2200. Moving on to router 5. Enable configure terminal, router BGP 2200. We have two networks here as well, 5200, mask 255.255.255.252. Right, I used the command neighbor instead of network. And then we have 5300 with mask 255.255.255.252. And then we need to list the neighbors. Neighbors are 5201, remote autonomous system number 2100. So that's router 1. And then neighbor 5302, probably. Let's check. What is the IP address here? Yes, 5302. Remote autonomous system number there is 2700. And that's it for router 5. Let's go to router 6. Router BGP 2700, we only have one network here, that's 5300 with 255.255.255.252 mask. Neighbor is 5301. Remote autonomous system number is 2200. And since we're already in router 6 and we have only static routing in this autonomous system, we're not going to do any redistribution. We're just going to advertise this inside network as well in BGP. So I'm just going to say network 20000 mask 255.255.255.224. And that's it. Our next task is redistribution. So we have already done that for this autonomous system. Now we only need to do it for the remaining 3 autonomous systems for OSPF, EIGRP, and OSPF again. What we will be doing with redistribution is we will be redistributing all the networks from inside of each of these autonomous systems into the global BGP table. Let's start with router 2. We will open the BGP configuration mode again, so 2500 here, and all we need to do is say redistribute OSPF 1. Then on router 1, we will open the BGP configuration mode. Here it's 2100 and say redistribute EIGRP 2100 because that's the number we used when we configured EIGRP. And then on router 5, router BGP 2200, redistribute OSPF 1 again. Let's check what's going on with these BGP routers. Have they learned all the routes? Do show IP route on router 2. We already see lots of routes here. So we do have some directly connected networks. We have the networks learned through BGP. B is for BGP, obviously. So 5.2 and 5.3 are these external BGP networks. They're obviously remote networks to router 2, so it's good news that router 2 has learned about these networks. Then we have also learned about 7.3.20. That's this network over here and this network over here. And then we have these networks 31, 32, and 33. These networks are internal in this autonomous system. So this router has learned about those networks from OSPF. And then we have our 99 network, and we have the static default route. We have not learned about the 183.2.0.0 network and the 13.0.81.0 network, so I'm going to have to check what happened there. Let's see if the other BGP routers have these very same results. Do show IP route. Yes, again, we are missing these two networks from the cable autonomous system, so let's see what's going on there. We have two neighbors here. The neighbors are up. We said redistribute EIGRP 2100. Well, maybe that's not enough. Okay, let me go back to the BGP configuration mode, redistribute EIGRP, autonomous system number 2100, and that's it. That's the actual command. So why are we not redistributing this? Do show IP route. Okay, from what I'm seeing here, it looks like we have not actually even received any of the networks from EIGRP. Let me check if I even configured EIGRP here. Do show run. Oh wow, it looks like we have not configured EIGRP here. All right, so we must have forgot to do it. Router EIGRP, luckily this is a mistake that's easy to fix. 2100 network 13.0.81.0.000.255, and that's it. That seems to have fixed it. Actually, I want to say no auto summary. Let's now go to router 2 and repeat the command. Now we can see this 183.2 network. Let's see if 13.0.81 is here. It is. This means that all the routes have been successfully redistributed, and it looks like all of our routers have all of the necessary routes in their routing tables. Let's try to test the communication. I'm going to ping from PCA to router 6, for example. Wow, that was fast. I didn't expect that to be successful the very first time. Please be aware that you have NAT configured in several places in this topology, so you will not be able to click on PCA and then click on this web server, and that will never be successful because the source IP will be this public IP address of this PC, but the destination IP will be actually the private IP address of this PC. However, you can ping from this server to this router, for example, because okay. Because when you ping from this server, it will go through NAT and go to this PC with a source IP address, which is 20.0.0.4. And then it will go back to this router, and this router will translate it back into the private IP address. So that's how it will work, but it can't work the other way around, because when you actually click on a device, it takes the IP address that's configured on that device. What we can do though is we can get into one of these PCs, well, not that one, and say ping, and then ping the public IP address of this web server. So I'm going to say 20.0.0.4, and we can see that this ping is successful with a 100% success. Let's look at the requirements for access lists, because I want to test if that is working before we configure those access lists. So we're saying ban anyone not belonging in the HFC cable network from accessing router HFC network via telnet. Ban computers in the 33.0.0.0 from browsing the web, but allow all other communication. Create a simple web page on web. All right, let's create this simple web page first. I'm gonna say services HTTP, and the web stuff already exists here, so I'm going to edit this index HTML. That's the first thing that opens up, and I'm gonna say, instead of Cisco Packet Tracer, I'm gonna say hi, and whatever, I'm gonna say welcome to your favorite Udemy course. All right, that's going to be our message. Save. That's actually in this index HTML page. And then I'm going to go to PCB, open up the web browser application, and then we're going to say HTTP 20.0.0.4. And we can see that we are getting this changed or edited or whatever web page, which says, hi, welcome to your favorite Udemy course. And there's actually some links here. You can go to these other pages that you can also configure here. So these are the pages that are linked in that index HTML file. Now, to test telnet, we will not be able to access this router unless the router has the enable password set. So let me just check, do we need to configure that for this HFC network? Yes. So we are configuring the access list for this router, but first I just want to test if we can even access this router, right? Enable configure terminal, enable password, I'm going to say Quince. And then what we also need to do is we need to configure a password for accessing telnet. But if you say no login, you will be able to access without a password. Don't do that. It's a bad practice, but for the sake of this exercise, I want to make it as simple as possible. So this is how you avoid having to use a password for your telnet. By the way, using telnet is already bad enough, so really don't do this in production. All right, let's now try to access this router through telnet. I'm going to say telnet 13.0.81.2, I guess is the IP address here. And as you can see, it's open. It didn't ask us for a password or anything. When you say enable, that's when it asks you for a password. I'm going to say Quince, and we are in. Now I want to exit telnet, and we can go to configuring our access lists. Actually, This video is already long enough, so I'm going to stop it right here, and then in the next lesson we will configure ACLs and also test those ACLs. So see you in the next exercise.